Welcome all. My alternate title for this is The Genome at Work in the Industry, because that's really what we're relying on. What happens with the environment and the genes interaction and giving us that marvelous final product. Now, if you've been paying attention to the news, you will note that they're talking about using your genome for customized health care. Well, essentially, that's what we're talking about doing with our grapevines, because we have unique materials. We don't have 1,000 years of experience on these, where we can do it by trial and error. We need to use some different tools and develop some different tools to aid us in this process. So, if you think about flavors, it's a combination of things. It's not just sugars and acid, pH. It's very complex. And capturing that, identifying it, can be kind of expensive. Our standard harvest parameters are weakly correlated with that mature flavor, and then the flavor that you're expecting in the product, the wine. So what we are looking to do in putting this owner's manual together is to establish baseline gene, metabolite, and sensory information that we need to identify the signature characters of our unique grapevines. And so then we can use that information to help guide future selections, to benchmark Dr. Damoto's trials, training systems, which one is going to give you that key flavor that you would like, looking for those signature flavor, mature flavors. So this part of the project is focused on year 1 and 2, and we're focusing on the 2 red cultivars, Frontenac and Marquette. We're going to be looking at the physical and molecular characterization of the berry. So how does the berry develop? How does the berry ripen? Now I know most of you have seen this diagram in the right in a trade magazine, right? That's how a berry does it, correct? That's probably Cabernet Sauvignon. And we don't have that information on those key time points for our cultivars. So what we're looking on doing is developing that profile in depth, and the chemistry that we're talking about goes beyond the chemistry we know to, we're also in a discovery mode. We're going to be finding unique components in our wines and our juice. And this is also going to use sensory evaluation. So we're going to be using different types of analyses and pulling them together in the end to help us identify biomarkers. Some people call this hypothesis-free research. Others, this is a discovery-based research. And that's truly what we are doing, is discovering the potential of our grapes. So we're going to comprehensively track what genes are activated, what metabolites are produced, products of those genes, and what sensory descriptors develop. And as you can see, we're going to be carrying out several different analyses there. This comes from a team of people again, and then it includes the statistical integration, some very powerful analysis techniques that help us hone in on specific gene families, specific metabolite families that are important for your product. So, as I said, this is a team. It's made up from 3 states, South Dakota State University, University of Minnesota, and Iowa State. The fruit development and ripening component, I will be characterizing and documenting the development of the fruit as well as the berry ripening through gene expression as well as physical documentation And then finally through a pathway analysis. What is that? Well, the grapevine was the fourth whole flowering plant to be sequenced, the genome. So it's shortly after the human genome was released, about 2 years. And this is going to build on my component and Dr. Hageman's and Devon's from Iowa State are going to build on some tools that we have developed. Since that genome was released, in another project that I have, we have identified the function, curated is what we call, the function of about 70% of the genes in the grape genome. So we know they're there, we know how many of them there are, and we've got what they do for about 70% of them. We can use that information with our chemical analyses and begin to get some handles on the important components that we need to be looking at. There's going to be some, as Jim said, some real cutting edge work being done. At Iowa State, they're going to track the volatile metabolites. The aromas start developing before we're raising. They have some very nice tools that they can capture the chemicals released by the grape cluster and then analyze those. And down in the bottom right, you see our leader of the project experiencing those compounds coming off the gas chromatograph, and he can smell them and poke a panel and say it smells like this, it smells like alcohol, it smells like moldy socks, whatever it smells like. And that work will be done in Dr. Kozel's lab down at Iowa State University, as well as the chemistry that we're used to thinking about and looking at will be done by Merle on these samples. The key thing here is that there's one source of samples and everything is tested from that same source so that we can, in the end, put it back together into a picture. At the University of Minnesota, Dr. Hageman looks at primary and secondary metabolites. Now, someone asked the question earlier, what's primary, what's secondary? What determines that? And my thought is, the first is what gets the plants there, the second is what's good for me. Dr. Hageman had a much more eloquent description of that, but it's the secondary, or now they're terming them a little differently, are the ones that you are most interested in terms of the products. It's that interaction with the environment, it's the things that we've selected for that contribute to flavor, that contribute to an animal eating that and spreading the seed. Those are the kind of things that fall in that secondary. This is truly a discovery mode, and linking it back to the genome, we will be identifying compounds that we wouldn't traditionally track. But we will be identifying them and using that in the end. Finally, the sensory part. This is very key because this human factor is what we need to pull it all together. So we will be doing sensory analysis of the juice and wine samples, wine made from these same dairy samples. And Katie Cook is the enologist at the University of Minnesota. She will be collecting the juice and doing basic chemistry, but then doing the fermentations. And Dr. Zeta Vickers is the sensory person on the team, and she will be analyzing those with trained panelists for things like aroma, sweetness, acidity, bitterness, other flavor descriptors that the breeder feels is important and the enologists feel that are important. The final thing on this, we have different types of data sets coming together. We have very qualitative information coming from the human panelists. We have particular chemicals coming from the aroma and metabolite analysis. And then the genes that are being expressed to produce those. How do you put that all together? With some really cool statistics, and I'm not spinning a yarn. This is being used in major wine industries, and I pulled an example here from a recent paper in Germany, where they're identifying the critical chemical components related to wine character in Germany. And so this is what we can do because we have these tools now. We have the genome, we have the technology to analyze samples in a way that we haven't routinely analyzed them before, and then we have the mathematics skills to pull that data together. So what we will be doing, just to recap there, is cataloging the berry ripening and development process, the resultant volatiles and other metabolites that contribute to flavor, using the sensory analysis to validate that, and providing the documentation on this new group of grapes to sort of speed up that 1,000 years of trial and error. These measures will be very useful in a part of the project that got cut because our budget got cut, but it's planned for the future, and that is in helping guide selection of new cultivars. But also, we can use them for benchmarking or measuring the impact of particular cultural practices, and then also providing the basic information there to develop tools that you might be able to use in the vineyard that you don't have right now. Don't you think it'd be really cool to go out in the vineyard, put a bag around your grapevine, stick a needle in there, pull that needle out, send it to Iowa State, and have them tell you, yeah, you've got your nutrition right because the terpenes are coming in right on track? That's where we want to go. So join us on the Starship Enterprise. And this is the team from the various universities, minus Merlin. Thank you.